Surveyors are often confronted with obstacles, such as trees, when measuring the boundary of a lot. One technique used to obtain an accurate measurement is the triangulation method. In this technique, a triangle is constructed around the obstacle, and one angle and two sides of the triangle are measured. Use this technique to find the length of the property line, which is the straight line between the two markers in the figure. So yeah, this term triangulation, I'm not a surveyor, or do I have any experience, with as a police officer or someone, like a detective, or even like any military experience, but this term triangulation, it's starting to make more sense in that if you can, angles are more easily measured between features, are more easily measurable than distances, because an angle is something, it's like scale invariant. It's like I could think about my field of view looking at a mountainscape. I can think about my head tilts left to right a certain angle, right? I don't have to have an intimate interaction between those far off features to figure out the included angle. So you're able to get angles, but then there's also situations where you're able to get distances. Like, if you have a location of a cell phone, well, then the distance from the cell phone to the cell phone tower, something like that, right? You know for sure what that distance is. So there's situations where there's known angles and distances, and then if you're able to solve triangles, you can solve for unknown distances that you would like to figure out what they are, right? Well, how do you solve oblique triangles? I mean, sometimes it's right triangles, but the majority of the time it's probably not going to be a right triangle. Well, law of sines and law of cosines, right? And so that's my understanding now of this term triangulation that you hear when they're trying to triangulate positions in the military and whatnot. That's what they're doing. They're in effect they're solving triangles. Pretty cool. Okay, so the surveyors are confronted with an obstacle here. And, this is not the best example. It's just a tree there. We'll just walk past the tree, but they're just trying to make an illustration here. You can think of, like in real life, maybe there's a big lake or something or whatever. And so, but they're looking to get this straight line distance here. And so instead what they do is, you think about those rollers, they measured lengths, like when you're trying to measure areas of land, let me pull in a picture of one. These. So, you zero it, and then you could just roll it, and it ticks up and shows you the total roll distance. That's how they just walk this along and get 18 feet. Mark that off. Then roll this, get 14, 13, and keep going. Okay, but then they're able to get that this angle is 70 degrees here. So can we use this information to get the distance from this marker to this marker? Well, to do that, we need this distance. Okay, so can we get that distance? Well, we have a triangle here, and we've got two side lengths and an angle. Okay, but is it side angle or side angle side? Well, it's side angle side, so we can use the law of cosines. Side angle would be the law of sines. So, okay, law of cosines. Let's do the law of cosines centered around this angle. Remember, the law of cosines is three separate equations, and you can apply it. It's like centered around one angle of the triangle. You just pick the angle you want. So we're going to be centered around this angle. So we start with the side length squared opposite that angle is equal to the sum of the squares of the adjacent side lengths minus 2 times the product of the adjacent side lengths, and then times the cosine of the angle. Okay. So x is going to be, we've got, let's see, cosine of 70 times 13 times 14 times 2. Okay, then we've got 14 squared plus 13 squared, and then we're going to be subtracting this from that. Okay, now take the square root of that, and there we go. So 15.5 feet. So the answer to this question is the distance from marker to marker is, so 18 plus 14 is 32. And then 32 plus 15 and a half is, so 32 plus 15 is what? 47. So 47.5 feet.